The subject of today's video is not this narrowed and malformed LED lamp that I crushed in a recent live stream. It is in fact this RF remote control switch with this handy little extendable antenna remote control. And the thing that got me interested in this when I saw it was this exposed metal here, and I thought, could it possibly be that this is from eBay and being shipped directly from China, that could be live? And you know what? It has not disappointed. Let me show you. I shall show you it with diode continuity, and I'll go to the neutral and to this, and it shows a diode junction, because that can actually give potentially a decent shock. I think this is a capacitive dropper in here. It might be a little inductive buck regulator, but we shall open it and explore in a moment. So let me plug this into the hoppy, noting that when I plug this in, there is a shock risk off this metal. This is not good. Now, can I mention, a lot of power supplies are sold with these terminals. This one's quite good because it's got a little cover, but a lot of them are sold with the open terminals. These are actually designed for mounting inside an enclosure, so maybe it's not so bad, because if this was mounted inside a plastic enclosure, then the metal would be out of reach of the public. However, having worked on control systems that have unexpected live metal in them, it's still not great, because the last thing you're expecting is for an aerial connection to be live. And if someone extended that out with a bit of wire, then it could pose a shock risk. So this thing is drawing a standby power of 2 watts, which is quite a lot. Power factor of 0.1. This kind of hints in the past that usually means about 24 volt circuitry and about 73, 74 milliamps. And the remote control simply goes on and off. That's it. There is an instruction sheet I found that kind of implies it does different things. I found it in another listing, but it may be for a different remote. This one just says AK WTO2 220 volt 433 megahertz switch transmitter wireless AB buttons remote control. The AB buttons might be the clue here, because it is the on off. And it's odd because it shows that it's available in a couple of versions, 220 volt and 380 volt, which is odd, which is the Chinese voltage between two phases, which makes sense for, because this seems to be aimed at motors and things like this. I'll be careful, I won't touch that. This seems to be aimed at pump motors and things like that, because it does apparently have a fairly high current rating, 30 amps. We shall see when we open it up. But to program this, you press and hold the button to delete the codes. You press and hold the button, the little red LED lights, and then after a while the red LED goes out. You let it go, that's it, deleted all codes. To program a code, you press and hold it until the LED light, oh actually, you know what? Let's not do that. Let's show that it's not got a code programmed, right? Okay, so nothing is happening, right? If you want to just use it manually, you can press the button and it will toggle the load on and off. If I press and hold it until the LED lights, then let go, the LED goes out, but then it's in programming mode. Press a button, it flashes the red LED, and it's now running from the remote. Apparently it has a huge range. I've not been able to test that. It's not a nice day outside to go into the distance, and I'm not even sure how to do that anyway. Right, tell you what, let's unplug it. Let's unplug it and open it. We'll also open the remote control. Things worthy of note as well. It says live neutral, and then it says live neutral again. So it looks as though I've miswired this because I've got it back to front, but in reality, it's marked wrong as well. Let me show you the continuity. The two neutral connections are actually in the middle. So this is me going between theoretically a live neutral and live out, which shouldn't be connected, but they are connected because it's labelled wrong on the case. Just under where it says made in China, it's labelled wrong. That's a mean thing to say, because China makes lots of good stuff as well. Right, okay, let's disconnect it. Let's get this open. So I shall take the wires off after I've made sure everything is unplugged. Nice big chunky terminals, that is a good sign. MD who's worked in maintenance will know what I'm talking about when I say that sometimes you go and work on a particular panel of a particular piece of equipment and it has mystery live metalwork inside. Just a piece of like equipment inside a big panel that doesn't look like it should be live and isn't marked as being live, but just a random bit of metal sticking out that's live. This is one of those. What is this going to be like? Is it going to be shitty? Is it going to be good? I tested the current of the remote control. Oddly, it's got a little slider switch at the side that you can actually turn it off. It says F and N. I'm not sure what that means. In F position, it's off completely. N position, it's active. Not sure what the F and N is. Maybe a different language for on and off. Big relay. There's the capacitor for the capacitive dropper. Oh, there's a metal oxide varistor as well. Is that just across the incoming supply? I think it is. Not sure. We'll find out. Ooh, that does come out. Right, tell you what. I shall take a picture of this and we'll reverse engineer it. It's based though on a little RF receiver module here, and probably a little microcontroller programmed to receive that code and then drive the relay. Okay, I shall... Oh, look at the size of the actuator on that button. That is enormous. Odd. Okay, that's one bit. Let's open this now. So this actually runs with a PP3 battery, which is quite odd. Be very careful when you're taking it out. I took one out earlier on and it stretched the spring. So there's a screw hidden under here. Is this going to fit? It's not going to fit. Let's just use a smaller screwdriver. This will be a generic transmitter chip, or it might be a microcontroller. You never really know. I would guess that based on most other ones, it will be a generic little transmitter chip, because they usually are. It's not opening. Is there a screw under there? Feels like there's something holding it. Oh, nope, nope, nope. Here we go. Here we go. Oh, there we go. So, things I'm seeing, 2 coils with, all right, and a crystal. This is 433 megahertz, by the way. The crystal is marked R433. I thought there might be one of the little dedicated RF transmitter modules. Maybe it's in the back. Is this held in by screws? No, it's not. There is nothing in the back except solder pads for programming, possibly. 2 buttons, the little chip, and it's designed to take 2 different chips. Right, tell you what, I'm going to take pictures of these and then we can explore them. I'll do a little bit of reverse engineering. Obviously, I'm not going to go right into the RF circuitry here because it'll be based on dedicated chips. But I shall take a look at the power circuitry and I'll see if I can find what these chips are. One moment, please. Okay, the reverse engineering is complete. Let us explore this. I shall just nod down this a little bit. So here's the unit here. Here it is close up. Slight out of focus here because I was focusing down on this area down here. We have the incoming supply goes to a metal oxide varistor. That's quite an unusually high voltage for that, but it is kind of presumably based on the fact that this is a dual voltage unit. You can have it set up for 380 volts. This capacitor here is a 1 microfarad X2, rated for 310 volts. And it has 2 discharge resistors across that. It then feeds this bridge rectifier via a 68 ohm resistor, 68 ohm. And then there's a smoothing capacitor which is rated 470 microfarad, 50 volt. The voltage is clamped by these 2 surface mount zener diodes. Now they're 24 volt zener diodes and they've mounted 2 in parallel to spread the dissipation because it's quite a lot of current. But it should be noted that you shouldn't really do that. You're not supposed to put zener diodes in parallel because it will result in an uneven current sharing. It would be more appropriate to get two 12-volt zener diodes and put them in series to get the 24 volts and spread the dissipation that way. The 24 volts then goes via a resistor and lots of decoupling capacitors to a 7805 voltage regulator. Then gets smoothed again by a 470 microfarad capacitor, again, but 25 volt this time. And that then feeds this RF receiver module and then this decoding microcontroller here, which then drives this little transistor, which then switches the relay on. So I'll show you this side of the circuit board if you want to have a wee go at reverse engineering it yourself. And I'll show you the other side of the circuit board, which looks like this and has been flipped accordingly. Things worthy of note. The big fat pads are pretty good. This is a bubble in the solder because they've cut the solder flush afterwards. It looks like it's been actually sort of ground flat, but it's just a bubble that's appeared in that solder joint, a flux bubble presumably, and it's not really affecting the connectivity. But there's the two neutral connections bridged together, and we have the live coming in and then the switch live output, which will be, let me just flip this round. So that's the live output here. Live out and live in. Other things worth of note, lots of anti-tracking slots, almost too many, some that almost seem pointless because they're between low voltage sections, but they've put lots of anti-tracking in. Anything else that's worthy of note? Nothing really. They've got multiple connectors here that are designed to take different modules. That's more or less it. And there's the connection going out to that live RF antenna. Okay, let's take a look at the schematic itself. I may have to zoom down in this. I shall zoom down in this. I'll take the exposure off. I shall lock onto here and I shall zoom up. So what we have, the incoming supply has a metal oxide resistor across it, 680 volt metal oxide resistor. There's the 1 microfarad capacitor with its two discharge resistors, and there's the 68 ohm resistor, which is really big. It's like a 2 or 3 watt resistor. And that just ensures that spikes and glitches on the outside can't ultimately find their way to the circuitry because they've got a lot. It's designed for switching motors apparently. They often reference pumps. And pumps being highly inductive loads are very spiky and glitchy and it can sometimes crash the processor. So they've got lots of decoupling. So there's the two zener diodes in parallel. It would have been nicer just to have two zener diodes in series like this. 12 volts each to actually do that, but they instead use two in parallel. It's fine, it's what they've done. There's a 51 ohm resistor to dissipate some of the power from, and also to limit the current through for filtering to the 7805 voltage regulator. A couple of small capacitors, little ceramic ones, the 5 volt regulator, a couple more ceramic capacitors, and then that electrolytic capacitor at the other side. The circuitry breaks down like this. We've got the 5 volt rail, which that is generated up here, that's the orange one. Powers the RF module, and the RF module only effectively, it's got 4 connections, but the 2 middle ones are common. I'll just draw that in like that then. So it's got the +5 at 0 volt, and it's got the output via 1K resistor just signaling to the input of the microcontroller, MCU microcontroller unit. The microcontroller also has 5 volts and 0 volts. And it has 2 resistors going out, two 2K resistors. One lights the little red LED down here, this little red LED. Another one drives this transistor down here, which switches the relay on, but the relay is powered from the 24 volt supply, just because that means it requires less current. It's the best way to do it with the capacitive dropper circuitry. So that relay coil is switched by a standard Y1 transistor. It's got a reverse back EMF or anti-flyback diode across it, which when this transistor turns off, it basically shunts the spike of the collapsing field. Because if you consider it, if this is positive and this is being pulled to negative, it builds up that magnetic field. When you disconnect it, this will then go negative, this will go positive, and it can result in a very high voltage spike because there's no load in it that can actually cause damage to the transistor by zapping it. That is more or less it. There's the RF output, the common 0 volt rail, which is alternately connected via a diode going that way up to the capacitor and a diode going that way over to the neutral. That means that because this is going out to the antenna, it's the little loop round antenna, it's the metal here, that is connected via a diode to the live on that end of the capacitor and the neutral. And that means you're going to get a sort of reference to ground, you're going to get half wave pulsing mains voltage at approximately through this capacitor. It's going to be about 75 milliamps, which is quite a significant current in terms of shocks. So if you extended this antenna out or put it in the outside, well, if you can't put it on a metal panel if you extended it, because it would basically just short it and cause current flow in the metal panel. But if you were outside and you'd mounted that and you went to adjust that antenna, you were on standing wet ground, you would get one incredible shock off that. Not great. Let's take a look at the remote control transmitter. I think I've covered everything there. Okay, the remote control transmitter, let's bring in the pictures of it. And we'll zoom out a bit so you can actually see them. So I shall zoom out. And I shall brighten that up a bit. The remote control transmitter has the battery connections for a PP3 battery. It has a polarity protection diode, and then it has a switch. When the switch is on, it powers the RF circuitry continually, but it's not enabled. At that point, the quiescent current is 0. I measured it. When you press these buttons, it actually transmits, it presents a code depending on which button you press. It turns the circuitry on, it turns this on, which is the little remote code transmitter. And that then sends pulses to enable this circuitry. And that enables the RF circuitry to go on in bursts. Now, there's a transistor here that enables this circuitry, and it's got a 433 megahertz crystal. That's presumably a little RF transistor there, which then couples to this amplifier stage with this coil, which will resonate at that frequency, but then couples again to another amplifier stage with this another RF amplifier transistor, and then via the capacitor to the antenna that sticks up against the outside. The reason it's got the two stages here, or the multiple stages effectively, is because that gives it buffer against, it's less likely to be affected by you touching an antenna and changing it sort of like its resonant frequency, or putting your hand in the vicinity of it would also that effect through capacitive coupling. So, but by using these two separate amplifiers, it just isolates that. I'll show you the back of this circuit board, which isn't very exciting, and then I'll show you the schematic. It's interesting, it's a bit weird. Things to note, these 10k resistors down here that are pulling up a code, this transistor, which is PNP, which turns that on, and then this transistor, which is NPN, which turns the RF circuitry on when powered by that. It's quite complicated. So this is that side of it, and here is the other side. Note these pads here. It's got two outlines for the chip because this circuit board can also accommodate a different type of transmitter chip that has what they call tri-state inputs. They can either be left floating or they can be pulled low or high, and you can actually set a sort of 3 possible codes on each one of those pins, which lets you set a code, which makes it a bit more manual because someone has to solder those in the factory. But that's the back of the circuit board. Let's bring in the schematic. And this is weird. This is a very, very weird schematic. Normally when you pushed a button, it would, on most remote controls, it would not only present through diodes perhaps to the code that actually tells it, which button's been pressed, but it would also use another diode from each button to actually power up the circuitry. But it's not doing that. It's using a very odd arrangement. So here's the battery. There's a protection diode. There's the switch that turns it on and off. And we've got, let's just say plus 9 volts. It's 9 volts minus a diode, but it's good enough. The EV1527 has a possibility to be programmed with effectively 24 bits. 20 of those bits for the codes, so you don't get crossover between, so one person's remote doesn't operate someone else's equipment. 20 of those bits are programmed internally. It's one-time programmable, and then that chip is programmed with that code. So when they're making these, or in the factory, they'll go through a piece of equipment that will just set a random code, it will just count through all the codes as they go through. And the likelihood of, it's such a high number of codes that the likelihood of you getting an equal code to someone in the vicinity is supposedly unlikely. But there's also another 4 inputs. I'll draw the other ones, which are normally pulled down with 10k resistors, but when you push a button, it actually pulls those up. And in this case, they've only used one button pulling up one contact. But here's the weird bit. To power this chip, they've got a PNP transistor that is normally turned off by this resistor here, pulling it up to the positive rail. But when you push the button, it doesn't just bridge it down to via those 10k resistors and turn that transistor on, but the current flowing through that transistor and the base actually is used to pull the inputs high. It's a bit odd, a bit strange. So that transistor then effectively, when you push the button, it doesn't just present one of these codes to it, but it also actually turns it on. And when it turns this on, this then sends a code out to this transistor, which then turns that transistor on, that pulses the RF circuitry on or off, which transmits the code. It's very strange. There's the 2 buttons feeding that plated through hole and that plated through hole, which relate to these. They go to either side of this. So technically speaking, you could actually set a different code by bridging the pads either way to either button, but not both. You can't, because then it would bridge the 2 buttons together. So you could say, for instance, this one could also do that, and you could actually use 2-bit code, or you could just remove that solder and actually just bridge another one. So you could actually, if you had matching, if you wanted different control, you could actually change the code roughly on these. But there's the transistor that gets pulled on by the buttons. Very strange. And then it powers that up while they're sending the code, and it also powers that LED just to show it. The LED does not show you the data being transmitted. All it shows is this chip has been powered. An EV1527. The other chip was a PT2264, the bigger chip, a more traditional chip. But then once this sends the code back down, it goes to this transistor here, and that's the one that pulses this whole RF circuit on and off to transmit the code. So it's interesting. It's an interesting design. It's a strange design. And it has that awful flaw that this metal just becomes live. I mean, that is the main bugbear about this. Technically speaking, you could just remove this. It's got that little antenna there, so it would decrease the range somewhat, that it could pick the signal up. But if you do ever get one of these, just assume that this metal is live, because even if it did have a switching power supply in it, you just never know what quality that supply is, whether it's got good isolation, and there is always the risk of a shock off something like that. But there we go. Interesting stuff. Nice solid relay, big fat tracks, totally mismarked in the case regarding live neutral, so double check that the 2 middle ones are neutral. And that's it. If you want to erase the codes, you just press this button in, the light will light, keep it held in, the light will go out, and then that erases all the codes. And then you can apparently, by pressing this for a few seconds till the light lights, then let go and press the remote, you can actually program up to about 30 codes. So it's quite a versatile unit. But there we go. Interesting stuff. Well worth buying for the shock value, quite literally, and reverse engineering it and seeing how it all works.